I'm not too sure if I have. So I don't have it really prepared because mainly it is supposed to be practice, like summary practice kind of course anyways, like class anyways. So I start with Bismillahirrahmanirrahim. Thanks all for coming. MashaAllah, we are at the end of our course, and we'll go through some of what we have done so far, and we'll try to practice a little bit, and we'll see where we go from here. But this is like lecture 8, so it's good that we have gone through all lecture 7s. Mainly, this is supposed to be a very practice-oriented course because programming is so much practice that it is kind of like unbelievable sometimes. Just like every other thing. It's just that there are quite a few moving parts in it, and there are quite a few things that one has to have good control of. Means there are no motor skills or something that it becomes instinctive or something. There are a few things that does with practice, but there are a lot of things that you have to keep doing and then remember to get better and to improve in what you're doing. So, just like always we start, is there anybody who want to show off their work, something that they have done? I know sister has done something, but she doesn't want to show it off, or you can send it to my WhatsApp group, and then I can take it from there into here, into would it work on JDoodle? It will not work on JDoodle? Or we can connect your computer with this thing.
Okay. I mean, I can show all of it.
Yeah, don't worry. I'll turn off the camera towards this one, so it will not show you.
Oh, okay.
All right, come on. Because one of the things about the programming is that you have to show off your work anyways. Means there are so many things that we have not talked about, but one of the things is review. So most of the code that should go in as a working code, put it over there. And it's not, the camera is not on that, so don't worry. And let me see what would connect to it. HDMI. There is an HDMI port. Let's see how does this work.
Okay.
Nice. All right. So it's all yours. Make sure that you are not coming in this. No, you're not. So don't worry.
I mean, this is like student grade.
Student grade. Okay.
Yeah.
That's nice.
So to get the grade, for example, like if I put 70
Mm-hmm.
and run, maybe C plus.
Oh, it's got C plus. So we see here that 70 is C plus. Let's see if the student gets 92.
If the student's 92, so
A. Okay, that's nice.
And the student is again.
60. D. All right, that's nice. So would you give a little bit of how you wrote it? The what are different parts of the code?
Just row.
So mainly if and else.
Yes.
So, and this is one of the things this is, which we can see is that this is nested if. So if and else, there's a big if and else, but then there is else, and then within the else, there is if. Very interestingly, while she has not used the squiggly brackets, but this else is one command, because if you do not use compound statement and brackets, then else can only have one command, right? But then in else, she has an if and then else again. So and then an if again and things like that. So it's all nested, and of course with this she must have checked it so many times that it calculates the right results. So this is a very good example of conditional statements and nested conditional statements. Thank you very much. MashaAllah. All right. Anybody else? Sir? No? All right. No problem.
I didn't do anything. I mean, if you have time, can you do the file again? The file print?
I was thinking more about doing some function a little bit.
Okay.
And we'll do it, but I just
If you have time, maybe toward the end.
means for file, if you're interested, we can also do it, right? That's not a big deal. It's just that if you go through the whole text and stuff, then there are enough examples. But still, means we could do it afterwards. Just because I'm not very prepared for a file, and just like I said, for file, it is done in so many different ways. It's not just that simple. One of the programming languages that I used to do was PHP. It's called PHP. It does file manipulation in such an easy way that it's so easy. And then once you start doing those kind of languages, then for you to go back to Java, which you are not using as your job, and then kind of learn it again a little bit, it becomes a little bit difficult. But the whole idea here, so we will go through some of those things that we have learned from the beginning, and then we will go a little bit into some of the concepts like practice and stuff, and we'll see how we practice. But one of the things that is kind of the most important part of this whole course was that we learn about some of the basic concepts of programming, not Java. That was the whole part. And then again, that's why I did not do a lot of file manipulation, which is all good in Java. It's not bad. It gives you a lot of flexibility that PHP would not give you generally that easily. It does give you, but Java had it so many different ways. It's just that I wanted to make sure that we do practice things that we will still go through a little bit, or at least talk about, but some of the basic programming concepts. Because those concepts are like the basic concepts. They are there for every language. So for example, PHP is very C-like. So once I started PHP, I had no problem as such. There was no kind of like learning curve as such. Of course there was every day a little bit, but I started working right away because the basic concepts are there. Even the syntax is very similar. Then just because you have the practice, you have the understanding of what you're doing, what are you programming right, what are the different things that you need to do to write a program. And we'll go, like for example, this is some other thing, but for example, design. We talked about design, right? So once you are given a requirement, you think about design. and that's first thing. That's not like which language you do. It's the first thing that you think, okay, I have to do this. And then you start thinking how it could be done. Now, this is not programming language. This can be done in any language. Like, for example, I'll need some variables, I'll need maybe an array, I'll need some conditional logic where the program will check for this numbers above or below, and then it will go and process some data based on this logic and something like that. And of course, if it's a bigger program, then you start thinking of functions, what functions you'll need to have, and then how it will be called, and all that kind of stuff. Again, and the more that you do, the more you will have. So all of that is irrespective of what language you are using. And then on top of it, once you start doing it, then of course, whichever programming language you are more comfortable with, or whichever you use as a job, that's what you do. So we started with from source code to running an application. Who remembers this part? So we talked about an editor, right? Now we know a little bit more, right? At that time, we didn't know what an editor is, or maybe we knew, but whenever you're writing a program, you need an editor. What is an editor? JDoodle, where we write, that is an editor. What she was showing, Eclipse, that is an editor. What do you do in editor? You write Java source code. What do you do with Java source code? What she did when she was showing us the code, she did run. When she did run, it did not mean run directly the code, because yes, so you have to go compile. Right, so you do compile. It does a compile, and within itself, it creates a class file. Then it uses libraries, combines it, and then Java Virtual Machine runs the program. Java Virtual Machine is like an operating system, on top of an operating system, but we'll not go into the details of it. Then while running the program, we talked about, this was also again the first class, we talked about syntax errors, right? We talked about semantic errors, and we talked about logical errors. Of course, we are not going to talk too much about it, even today, because today we'll try to finish at 9:30. If we want to stay for something, then we'll stay a little bit, but errors, right? If you're writing a program, for example, you wrote a program, you must have encountered a lot of errors, right? Sometimes you do not do the comparison right, and then it should be a C, but it is showing as D. Or maybe that in your case because you were very meticulous, but in other cases where people could be seeing that will be a logical error. The program would run, but instead of showing a grade as C, it is showing a grade as D, for example, right? That will be a logical error. And of course, syntax error we have seen so many times. You forget a semicolon, and it will be a syntax error. Whenever you do not follow the norms of the programming language. So for every programming language, that norms are different. For example, the programming language that I use these days does not have a semicolon at the end. But most of the other programming languages, they use semicolon at the end. So there could be a lot of errors. Once you are running, you see the previous screen, once you are running the program, doing a compile, you might see errors. Then you are doing running, you'll see errors. And those errors we have to fix. And then keep doing the same thing. And what is the same thing? The edit, compile, verify cycle. Which means this is a very common thing. So you might be saying, what is he showing? But this is like the process, software development process. So, and some of the different artifacts, some of the moving parts of it. Like editor, you have to know some editors. Compiler, what is compiler? What does compiler do? We're still not going too much into the detail, because if you really come across that, and you really have to learn a little bit more, or do this at a job, then you might want to learn a little bit more. But at least you'll have some concepts of it. And it's the same with edit, compile, verify cycle. Means a lot of times when you're a programmer, you want to write a program and then give it out and say, okay, this program is done, I've tested it, and then use it or something. But it might still have a lot of program errors. Because it's a big program, you cannot test it thoroughly. there is a big methodology on how to test a software. And there are so many testing techniques that you have to do. And this somehow comes to that. Say, for example, you're writing a code, and there's a syntax error. It will not even compile. So syntax error, it will not compile. But say there's no syntax error and it compiles. Is it error free? No, because it can still, when you run, there are other errors, right? So what do? You go back and you edit, and then you fix that error. Then you compile again, and then you run again, and things like that. So some of the things that you have to kind of think about. All right, our first most important thing of programming, data types. What is data and data types? Program is two things, data and operations, right? There are so many different data types, right? Primitive data types, built-in data types, library data types, user data types. We have not discussed all of it. I just brought it up because I took some of that from previous of the slides. But we said data types is a bigger thing. But one thing that shows actual as what a data type is a variable. Data type is a concept, but the actual thing of the concept is variable. So, for example, furniture is a concept, but a table is an actual of a furniture, right? So, data types can be so many different things, but variable is something we know a little bit of. So, what are the four characteristics of variables? No, that's not characteristics of variable. So integer is a type, which is a characteristic of variable.
Definitely.
So variable can have or has to have a type. And that type is similar to data types. But how do they come together? That where I'm saying data types are a bigger picture and variable is part of, kind of part of it. But at the same time, variable has a type which is part of data type. So it's like interdependency and kind of a little bit interesting concept, but no problem. So one of the characteristics of variable is
Initialization?
Type, right? Type.
Type, yeah.
What else? Initialization? Not really. We'll come to it.
Declare.
Not really, but we'll come to it. We'll say name. Right? So every variable has to have a name. When we declare, so think of when we declare what we give. A type and the name. Right? But then these are two things that are visible, right? What are the things that are not that visible? Storage. So think of the picture that I had where there were boxes to put things. So one of them is memory or storage. Fourth, I can't remember myself. All right. So what are the different operations on a variable?
Definition,
Define,
initialization,
initialization,
the value,
assign.
assignment.
Right. Give a value, which could be done as part of initialization, or which could be done as part of assignment. So both of those things. And assignments. So if I assign a value to a variable once, it will be initialization, right? The first time. If I do another assignment, what will happen to the first one? So there is a variable A. Override, right? So it will override. The first value will go away. There is no versioning or there is no backup or anything. So if you reassign, it will go away. And then so the fourth one is scope. We did not talk about it much, but we did talk about it a little bit within the compound statement. So we said name, type, address, value. Name type, we can see. address is a memory location and the value of the that the data type has. So the scope is like force, or it's not really properties. So we talked about expression, and I'm sorry I was not able to fulfill this empty slide. What about expression? What are the two types of expressions?
If and else.
No. We'll come to that. Expression. We talked about expression. So, mathematical expressions and logical expressions. Yes. So, what is the result of a mathematical expression? Some number or some result, a float or a number or something. Yeah. It could still be. It could be a string also, even sometimes. Very little. It could be a character or something. We've not looked at it. It's not very common either. But an expression is like a mathematical expression, like calculation, right? X times y divided by this and that, right? What is the logical expression? That the result is Boolean. And then she has used it in this program. All the ifs and else, they work with Booleans, right? So, conditional expressions. What is the, and actually it should be conditional statements. So what is a conditional statement?
Plus if and else.
So I'll not, if else. Not really for me. So if else, right? And we have seen some of the examples of it. The next is loops. What types of loops we have discussed? While loop, for loop, right? And then there is another type of loop that was part of, which one? Do while. Very good, very good. 100% numbers. So means full marks. So we have while, do while, and for loops. We'll not go too much into the detail, and we'll go into input output. So when we said input output, what are the different types of input streams? You can read it from this keyboard, from the screen, Brother Abdul-Bari.
Input streams are keyboard, file, and internet resource.
And then what are the example of output streams?
Video and file.
So why we say stream? For example, give me a keyboard as an stream example.
So why do we call it a string?
Mm-hmm.
Because it's a sequence of data that all goes into it.
Right. So when you are typing on a keyboard, as fast as you could be, you'll only be typing one character at a time. Or as slow as you could be, you could type one and then the next and the next and the next. So whenever you're talking about stream, usually it means character stream. In this case, input-output streams, usually it is character stream. Or it could be some other kind of stream also sometimes, but usually it means character streams, and character streams means one character at a time. So the first character, the next character, the next character, and then there could be some delay in between because it is asynchronous stream. And that's why there are so many different types of programming or libraries within Java that helps Java deal with asynchronous nature of a stream and how to read from it. But keyboard is a good and easy example, right? So your program asks the keyboard to give you a name, right? Your program says, I want to read a name from the keyboard. But there could be nobody writing the name right now. They could be on lunch break. So it will wait. And then somebody comes and it writes very quickly a name. And then it hits enter. It's still a stream, it still sends all the message, but when it hits the enter, your program says, okay, I got the enter, so I am done for now. And it'll take the whole stream of characters and put it in a string and give it to your program. So that's what usually when you do scanner, that's how it usually works. We also talked about a little about objects and classes, but not too much. We can talk about it if we want to after the class. We did talk about files, but again, files, there's a whole lot of things. Files, I was hoping that we'll do a lot of exercise of files, but again, to do all of it in the class is not that simple. So that means I was hoping that there will be a lot of practice with files, because one of the things that we learned about files is that files are the most important mechanism for storing data permanently on the mass storage device. So most of the data that you see in the whole world is one way or the other eventually goes into a mass storage device as a file. So all the databases, big or small, this or that, eventually they have to keep the data somehow safe, right? Because every computer can have a power spike or some hardware fail or something, and then the processor is not working anymore. Once in a while maybe, once in a lifetime maybe. But then your valuable data cannot just stay in the variable. It has to be stored somewhere so that if something bad happens, or if you restart your computer or anything, then you can start from the same place. You can read it again. So for example, if I wrote a program and it took 10 names, the program took 10 names. So I sat down and I input 10 names. And if all those 10 names went into an array, and then I shut down the computer, what happens? It was all in the memory. The memory gets wiped out when you shut down the computer. Which means for a very basic program, what I'll have to do? I'll have to save it in a file, right? So that's for the very basic program. And then a lot of other things, configuration, all those data, they can easily be saved into a file, and when the program starts again, it can read from the file again and then come back to the same state, right? Or do a search or something. What about databases? You can use database, right? But what about data? But database is still the same thing. It's a program. Inside the database, there are files. Somehow it uses it much more interestingly and much more nicely in a way that it makes it very fast and how you use it. But at the end of the day, when it has to save it for a long term, that's still a file, some kind of file, some way of file, different types of this or that. But eventually everything gets stored in a file for long-term storage. So that's why files are one of the most important mechanisms. And this is something that there are so many different uses. Of course, we cannot really teach about it here. But this is something that if you want to practice more, if you want to keep working on a little bit more, then we can talk about it in our WhatsApp group, and then we continue working on it a little bit. But for now, I just want to make sure that we understand the concepts. That most of those things that we are talking about is it's common in every language. That's what every language does. Processing is mainly conditional statements, mathematical statements, if and else, loops, working with files. Yes, sir.
Can you use Java to make a key login software?
Key login software.
Key login, yeah.
Key login mean?
It records all the keys you type.
Yeah. But so one of the things is that if you want to, so anything that, so one of the things is that you have to understand when you're doing like low level work like this, you have to understand that operating system helps you in a lot of this stuff. So all of the I/O, like screen, keyboard, even files, are all managed by operating system. So Java could do something that operating system does in replacement of operating system or in addition to operating system, but then you have to know really low level how operating system works and how Java will go in and change it. Sometimes, and especially for Java, sometimes some of those things which could cause some kind of security violation would not even be. And I don't know if this would be or not, because I don't do that kind of low level stuff. So we also talked about file operations, which is that once you are reading, so the file operations are creating, reading, writing, renaming, and deleting. Some of that we already know, because we work with the file, and we rename a file, we delete a file. But when you're doing programmatically, then you can do some of that things programmatically also. One of the things that we talked about last time about files is that when you are reading from a file or you are writing to a file, then there are two things. One is that when you are doing any operation on the file, you have to first open the file. And then at the end, when you're done, you have to close the file. That's one thing. The other thing is that once you are reading from a file, you can read from anywhere in the file. This is called random access read. So read is random access. But once you are writing to a file, you cannot write random access. You cannot write any place. You have to write only at the end. Which means that if you have to write in the middle, then you have to do some more programming. Like read the file till the middle and then put it in like a temporary file, everything from the start to the middle. Then when you are at the middle in the temporary file,